Hello. So I want to tell you about streaming money. I am Dietmar of the Lab 10 collective. We are located in Graz, Austria, nearby. So streaming money, this is the visualization our designer came up with. By the way, I'm not presenting on my computer. It failed me to connect to HDMI, so I have to present on a Windows machine. Let's hope that goes right. I'll try. So first, a bit of philosophical background. Thinking about money. So this is my observations. It's not some scientific classification. There is money which is self-contained in the sense that it has intrinsic value. So for a long time, we had these coins which were either of gold or silver. And there is the kind of representative money, which is more like a ledger, which, by the way, also existed already a long time ago. I think in Mesopotamia, they already had kind of ledger entries. And there are hybrids, like I found this Scheidemünze. That's basically coins like we have them today, without intrinsic value, or the paper money. If you look at old dollar bills, for example, they have written on it, for this bill you can get $1. But over time, it became basically the dollar itself. So overall, what's becoming obvious is that money is always solid. So material money is so far always out of solid material. And the picture is, maybe you know this rye. I think they are called rye stones. And if you're interested in that topic, I recommend you to read an article of Nick Szabo named Shelling Out the Origins of Money, which is very interesting. And related to that, types of transfer. So the money transfer, as we know it, is always discrete. It's in a point in time. And you say, for example, if on Ethereum you make a transfer, you have a receiver address and you have an amount, and it happens in a point in time. Continuous, we don't really have that. I put this picture of a pipeline. We have that for things like gas or oil, but that's not really money. And hybrid, I would say recurring payments somehow emulate that. So that's for relations which are continuous, but we emulate continuous payments with recurring payments, with recurring discrete payments. So the question is, could we imagine it otherwise? And I found this one, which is proof that, yeah, we could imagine it. In the 40s, they built an analog computer which works with water. There's also a video where I can briefly show you this in action. So water is flowing, and there are various levers where So what he just said is, let me balance the budget by moving some lever. They built this machine to simulate the national economy in the UK. So it was built by economists there. I think they also used it in New Zealand. And yeah, I found that pretty interesting. So yes, we could imagine it otherwise. The problems with the status quo, in my opinion, if we emulate continuous payments with recurring payments, that increases the liquidity requirements. If you look at example, payment channel solutions, you always need some kind of upfront deposit. You have increased trust requirements because if the payment is not continuous, then either the paying party or the receiving party needs to trust upfront. And you have usability and cost barriers. So I put this screenshot of where you can donate to the Electronic Frontier Foundation. And for example, they have $2 per month as a lower bound. And I guess that's because of the cost which is incurred by these recurring payments, which I think is a pity. There was a talk of Andreas Antonopoulos in 2016 where he talks about streaming money, which inspired me, which made me think about it for a long time. But there he narrated it as, yeah, we can basically stream money with payment channels. And you may know the Raiden demo, which took place a while ago, where they paid for electricity, and there was a micro payment every 2 seconds. That's a screenshot of it as proof of concept. But I kept thinking about that, if we cannot do that in a more real way. And I came to the conclusion that, yes, we could. And that's how it can be done on-chain. So right now, if you look at the Ethereum code base, the balance is stored explicitly per account. It's, I think it's named value there. Instead, we could make this implicit and define a function over time. And the balance basically is always a function of time. So the balance, if there's open streams, the balance changes, always changes. So it depends on when you check it, what the balance is.
It's like lazy valuation.
Yeah, basically. So an open, the transaction for opening a stream, instead of defining receiver and amount, defines receiver and the flow rate. And we get the state change, because if the balance changes, that is a state change. But we can get that state change by leveraging the change of block timestamp, because that's also a state change. And we just need another transaction for closing it, and that's it. It can run for as long as we want. And this is really continuous and we don't settle with every block or so, but it's limited to the granularity of the blocks in this case. I made a proof of concept, which is basically an extension of ERC20. So after a while, I figured out that could even be done for an ERC20 token. And we named that stream with double E, a term which is similar to the stream we know, but a new word, because I think that often if we reuse existing words, that's dangerous, because we have these leaky abstractions, where things behave differently than we may expect. So maybe thinking about it, you already thought, okay, that's nice, but what if the sender runs out of funds? We cannot just pretend that the sender will always be solvent. So indeed, that's the most difficult part. If you build that in an unrestricted way, where we can open streams however we want, then we can end up with a graph which becomes uncomputable. Because in order to calculate the balance of an account, I need to calculate the balance of incoming streams. And in order to do that, I need to check the balance of the sender accounts. And so I get into recursions which may go on forever. I can have cycles. I could even have nested cycles, etc. So that said, assuming that we can always compute that, we have a guarantee that if at a certain point in time we calculate the balance of an account, we can be sure that it will not decrease. So if I have a certain balance in an incoming stream, that stream may stall, or it may run with reduced speed, but it cannot reverse. So that means that the funds which arrived at the receiver can immediately be used, are immediately available. So I don't need to close or settle or something the stream. It's immediately available. So it's not blocked liquidity. And more about this complication later. So advantages over recurring payments, because we have this emulation. And I found something interesting, again, Antonopoulos, on his Patreon page, in the FAQ, there is also this question, why aren't you fundraising in Bitcoin or in other cryptocurrency? And he's saying, yeah, because doing recurring payments with crypto is currently difficult. And I think that's a pity, because we have now programmable money, and I think it should not just be as good as the legacy systems we have online, but it should actually be better, in my opinion. So advantages are we can reduce the transaction costs. We can reduce the trust requirements, as I said. So basically that means if today you make a recurring payment on the internet, you always need some kind of legal agreement because of this. And I would say that if we have something like streams, we could maybe get rid of that. And related, we could improve privacy, because if I need to make an account and give my details, etc., that always means I lose my privacy. I could not make a subscription to an online newsletter or publication without compromising my privacy. And I think that new use cases could be unlocked, and we prepared an example visualization of how this Patreon subscription could look like. So first I will just let it run without comments. So at the left side we have the status quo, how it works now. So let's assume we come from Twitter or somewhere, we come to this page, we are not logged in or something, and we say, okay, that's a good guy, he is doing useful work, let's support that. And at the right side, how it could be, and we have a counter time and counter for the number of taps on the screen. So maybe you noticed that we didn't even go for the worst case. We used Facebook login. We had the field, for example, for PayPal already with the auto-completion. We had a bad short password. So the worst case, I would argue, has a lot more tabs and takes more time. But I think it's already obvious that it's pretty painful. Maybe you can feel the pain when seeing this. So we also didn't have what usually happens, that you will mistype a few characters, and yeah, and I think it should be much easier. And let me start it again to briefly comment how it could maybe be. So here we slightly changed the screen. It isn't shown, but what could be done here is if you move the slider, then below you change what is included, because it's a mix between subscription and donation, so you also get something. Start stream could, for example, open a specific screen of a wallet app. On Android, for example, that could be done with an intent where you pass the parameters, where you have the receiver and the flow rate and some meta information which can be shown. So this would be a native component where the key for starting the transaction is stored safely in your phone, and depending on the flow rate, you could say, okay, it's enough to confirm with my fingerprint, as is done here, or with a PIN. And you could say if it's a higher amount, maybe you need additional, I don't know, maybe a second factor, etc. That could be user configurable. The point is that the website doing this doesn't need you to register. It can just be an URL which calls into this native app. And since this causes a transaction on the blockchain, so this would be opening of the stream. The Patreon server could listen to this event. There could be a token which identifies this particular stream, and you don't need more. You could basically also have automatic login with this step. So let's go back. Compared to payment channels, you do not need the extra infrastructure of payment channels, which is the sender needs to have a device always on, the receiver needs to. I think an issue which is maybe not enough mentioned is you need a hot wallet, the sender side, if you want to keep doing small transactions. And especially on mobile, it's a bit difficult to always be always on, etc. And of course, you don't need these upfront deposits, and overall, you have reduced liquidity requirements. And I think there should be a lot of use cases where these are important advantages. Just these days, there is a lot of talk about subscriptions. Maybe you're aware of the ERC 948 proposal going on Ethereum. And yeah, maybe this could be something useful there as an option. And I think that subscriptions are a good thing because they are emerging as maybe the only viable alternative to ad-based online business models, which had a lot of bad side effects, I would say. So.
What about the idea of, since you can, or theoretically in this new world, you can do micropayments, the idea of just paying for every little thing you consume rather than like subscription-based, right?
That is also an option. I think the problem with that is if you don't completely automate it away, that will not really work. There's another interesting writing of Nick Szabo. He wrote that in the 90s, where he said microtransactions are failing because of the cognitive transaction cost. And I also do think so. And I think that's an important reason why subscriptions still have a place, even if you could do this exact calculation of exactly what you need to pay. So briefly back to the challenge of computability. I believe that it is possible to have a design which has low restrictions, but where you have a set of rules and a set of dynamically adjusting transaction fees, so also continuous transaction fees, which would keep that computable. But at some point we decided that that's not an easy thing to do, and it's better to start with something simpler. We introduced 3 account types where there's rules who can stream where, and with that set of rules, which we call basic streams, we don't have the problem. We can't get into endless recursions, we cannot have cycles, and I think it's already useful enough for a lot of use cases. So that's how we are starting. That's what we are now implementing in Artis. We are right now implementing it in the parity code base. So we are building a version where we can stream the base unit of account, which we call ATS. We want to make a token standard, a streamable token standard, which I guess would also be compatible to the existing Ethereum protocol and Ethereum mainnet. And we will focus on proofs of concept and pilot projects to get the idea out there and see what others come up with. And we will focus on on the user journeys, because I think that usability is something which has become extremely important, and is very important for technologies to be adopted. And in general, for decentralized technologies to succeed, I think we need to become much better there. Briefly about Artis. Artis is basically a fork of Ethereum, so not a fork of the network, but a fork of the protocol. We make some modifications. I think there are some things we can try, or which we would try to do differently and see how this works out. One is swap out the proof of work consensus with Tendermint. Distribution-wise, we want to distribute most of the ATS to so-called anonymously registered unique humans. So we are working on a registration process, which we are very aware is a difficult challenge, but we're trying, where humans can get registered without leaking much information, but enough information to be able to duplicate checks. So basically we want to provide everybody who is interested with a share of this common resource. So with the ATS for making transactions on this network. And we are building in stream support. And related to Swarm, maybe this kind of continuous payment could also be useful for Swarm, because there are cases in Swarm where you, for example, for long-term storage, where you have this kind of setup where you need to continuously pay. So if that sounds interesting, let me know. And I think we are also interested in making Swarm part of the Artis network. We have a hierarchy of nodes where the so-called free nodes are supposed to provide services to the Artis members, and decentralized storage could be part of that. For example, that every Artis member could have some share of this, some amount of storage available. Yeah, that was it, and thanks again for having me.